This next question says, at the Fermilab Accelerator in Batavia, Illinois, protons having a momentum 7.38 times 10 to the minus 16th kilogram meters per second. So my momentum is 7.38 times 10 to the minus 16th kilogram meters per second, are held in a circular orbit of radius 1 kilometer. So my radius equals 1,000 meters by an upward magnetic field. What is the magnitude of this field? So I'm looking for my B field strength. Now what I know is that I have these protons, they're moving in a circle. The reason they move in a circle is because they have a force that's directed towards the center of the circle at all times. And that force, therefore, is a centripetal force. So I know that the force, in addition to having to do with the charge, the velocity, and the B field, it also has to do with centripetal. So it's going to be mv squared over r. So I'm looking for the B field. So my B field, to get it to move in a circle, is going to be mv squared over r divided by q and v. But here the v gets rid of one of those. So my B field is going to be mv over qr. So that's the strength of the B field when I solve for it. Now, conveniently, this is mv, so I don't even need to know the mass of a proton, because this p, that momentum, is equal to mv. So luckily I've got that. The charge on the proton is the same as the charge on an electron, 1.6 times 10 to the minus 19th coulombs, and you know the radius, so you can solve for B pretty easily.